going to be taking a look at containers as a solution for managing scene complexity. We're going to show you how to collect the objects into a container. We're going to discuss overriding the display properties, managing viewport performance by loading and unloading containers, and managing file I/O performance. For scene organization, containers act like groups. They allow you to combine multiple objects into a single entity. Let's take a look and see how to do that. To create a container, all we're going to do is go to the Create Command panel and choose Helpers, and we'll choose Container, and we'll create the container right there. Then we'll go to the Modify Command panel, and we're going to say Add. So once we add local content, I choose the selection set of the objects that we're going to add to the container, and I choose Add. These objects have now been combined into the container. If I move the container, it basically works just like a group in that it allows me to translate, move, rotate these objects just as if they were part of a group. If we go over to the Modify Command panel under Local Content, we see that we have the ability to save the container. So we'll go ahead and click the Save button, and this will give us the ability to give it a file name, and I'm just going to overwrite a pre-existing temp file, and we'll say Save, and yes, we'll go ahead and replace it. And now this scene information, the content that we put into the container, is now saved outside of the Max file and is being referenced back in. You'll notice that the container is still open. Remember that we added the content to the container and then saved the definition file and then referenced it back in, but we were still able to edit it. This helped us with the performance in that the data was referenced from outside the file. We can take this even further by fully closing the container. The definition file is resaved. The material is still referenced back in, but notice we can no longer select it to edit it. So it's truly a reference within our scene. This will give us greater performance on this scene or any other scene that has this container within it. So you see a bunch of other containers in the scene, and you'll notice that they are closed and they have a label and their status is reading as openable, which means that they can be opened. The content within here has been saved out as a maxi file and is being referenced back in. We can't actually select these objects because the containers are closed, but we can of course select the containers. We can improve our performance even more at this point by go ahead and selecting all of the containers. So I'll go ahead and turn on my helpers filter and we'll just select all of the containers and we'll go to Tools, Containers, and unload the container. Now what has happened is the assets within the containers themselves have been unloaded from the scene. This unburdens the video card so that we can continue to work quickly but yet have access to the content should we need it back into the scene. So at any time I can grab this container, Tools, Containers, and reload the container and the content comes right back. If we want to bring the sidewalks back, Tools, Containers, load the container, and it comes back. So you can see this is really an efficient way to work. In fact, we can actually see this. Here I've brought up the folder showing the Max-C files that I'm working on as well as the Max files that I'm working on. And here you can see an example of a Max scene with the containers open and the containers closed. The content is loaded into the scene still. Even though it's referenced outside, it's still there. Once the containers are closed, the data is essentially removed from the scene. And you notice the Max-C files all contain all of the data that's within there that, if added up, would equal the amount of data that's in our scene, or at least what the containers represent. So you can see that using containers will really enhance the performance of load, save, autoback, and hold. The last thing that we're going to look at with scene management in terms of containers is the ability to control the display properties of the containers themselves. You can see that our scene has been set up very specifically with all kinds of different layers and the appropriate objects on the layers. For example, awnings on the awning layer, chimneys on the chimney layer, doors and door elements on their own layer, all the glass on one layer. This might make sense in a lot of different work environments, but when we're using containers, each one of the containers may contain an element from every one of these layers. So although you can still turn the layers on and off themselves, you also want the ability to control those properties in terms of the containers. So what we can do is we can select a container, and over here we have the ability to override object properties. So all we have to do is turn that on, and now all of the object properties for the contents within the container are disregarded in lieu of the object properties for the containers themselves. This gives you the ability to then put the containers on their own layer and control the display properties of the containers specifically, and those display properties will then propagate themselves down to the contents within the container, overriding any previously set object properties. Now, these object properties don't go away, they're merely overridden while this button is on for the container. Once we turn the button off, any previous object properties for the contents that are within the container come back and are restored back to normal. So there are a lot of options for using containers for scene management and scene optimization that will really speed up your workflows and processes.